math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping.
Hello, everybody out there. This is Mr. Witt with Fort Bend Tutoring, and today we'll be covering the College Algebra Final Exam Review Part 1. We got Cherry Bomb in the house already. What's going on, Cherry Bomb? How are you guys doing? How are you doing? And we're going to be starting out with number 1. That's right, Fort Bend in the house. Fort Bend with a D, Cherry Bomb. All right, so starting out with the jokes already. Jamilio is in the house. What's going on, Jamilio? How's it going there? We're going to be doing for College Algebra Final Exam Review. Anger Hermit's in the house. Doreen is in the house. Good job, guys, chiming in. We're going to try to get through as many problems as we can today as we go over this final exam review. Doreen says, you are a lifesaver. I am doing what I can. Rosa Atkinson is in the house. That's what's up. Thanks for this. Finals next week. You better believe it. Big Vaquera is in the house. What's going on? Heather's in the house. Hi, Heather. So here today, we're going to be covering quite a few of the problems that you'll be seeing, guys, on your final exams for college algebra. We'll be going over those. All right, then, Angry Hermit. Benito Applebum is in the house. Good. Thank you for catching me live. Latara Felix, I'm awesome. You're awesome, Latara. And go ahead and be kind, guys, and go ahead and share this stream with everybody. So I'm sure that you know people that are also in college algebra. Go ahead and share this stream with your folks out there on Facebook, the people that you love, the people that you hate, the people you barely know. And your student groups, go ahead and share the stream with them as well. Let's get as many people as we can in here so we can help as many people as possible with their college exams. That's right. Go ahead and like the stream. If you're not already subscribed to Fort Bend Tutoring, go ahead and click that subscribe button. If you like the content that we provide to you guys for free, go ahead and click that bell icon so you'll be aware of when we're posting content, whether it be live or not. That will be helpful to your academic careers. Yeah, I know. So go ahead and hook that up for yourself. Go ahead and spread the love. And if you see there at the bottom of your super chat window, there is a $sign next to that emoji symbol that you can use to do a donation, a live donation to Fort Bend Tutoring to help us in our endeavors with spreading free math tutorials to the world for free. That is right. So go ahead and chime in on that. We'll show you some love on the during the review if you do so. And if you're unable to do that for whatever reason, you can also use the donation link that you'll find in the description box. That is what's up. Bonita Applebaum says that he has been a subscriber since, he or she has been a subscriber since 2014. Now that is some serious love, Bonita Applebaum. I appreciate that commitment, that patronage to the channel. Let me know I'm not out here by myself. You know what I'm saying? That'd be terrible if I was just talking to myself the whole time. You know what I'm saying? So let's start with number 1, guys. Let's get into some math problems. Here we want to find the center and the radius of the circle that is in the form x minus 2 squared plus y plus 3 squared equals 36. Now, if you're not familiar with the form here, the radius form, the center radius form of a circle, it is x minus h squared plus y minus k squared, let's get that right, equals to r squared. So this is what they're referring to when they're asking for the center and the radius. Latara says, you helped me pass my GED. You're very welcome, Latara. Congratulations on passing your GED. That is an awesome feat. Good job, lady. Fantastic. So the radius that they're referring to is just going to be your value of r. So in our case, we just need to take the square root of 36. So in order to find out the radius, you take the square root of 36. So that value of the radius is 6. What's going on, Charmaine? Let's go ahead and fix that 6. I hated that 6. The 6 was ugly. So we got to have a pretty 6 up in this piece. All right. And now for the center, okay? For the center of our circle, that's going to be h k. So we need the opposite values of what you'll see inside of the parentheses there. So for instance, the value -2 is the opposite of h. So we need to change the sign in order to find out the x value of the center of our circle. So that means that the opposite of -2 is going to give us +2 here for the center, for that x value, and for the y value of the center, you simply change the sign on that +3 to get a -3. Yeah, that's it. So as far as the center is concerned, your center for this circle is going to be 2, -3. And the radius is 6. Pick up the sticks. So let's go ahead and red box it. That's right. Starting off, getting these answers right, and putting them in a red box for the people. There you go. All right. Well, that's number 1. You know what I'm saying? Just get through these problems. That's all. Now check me out with problem number 2, guys. That's right. You thought you had to wait to the end to get to the logarithms? Nope. I hooked you up with problem number 2. What's going on, Empress Hodge? Happy Thursday to you. So here we have problem number 2, where we're asked to solve a logarithmic equation. Oh, yes. And when you're solving logarithmic equations, you need to keep in mind that the domain restriction on your logarithms for any logarithm is that you can't take the log of a negative value nor 0. That the logarithm that you're trying to take has to be a positive value. So that is going to be one of your domain restrictions. So you need to keep that in mind, because you may end up with extraneous solutions as a part of your results. So on the left side, I'm noticing that I have the log base 3 of x plus 5 minus log base 3 of x equals to 2. And so with those two logarithms on the left side, I want to combine those. And anytime you have a difference with a common logarithm with a like log, then you can combine that using the quotient rule for logarithms. So I'm going to rewrite this by showing that this is the same as log base 3 of x plus 5 divided by x, and this equals to 2. Yeah. That's what I have. And we can use our logarithmic conversion, all right, as one of the strategies in solving this problem, this equation, as showing that in logarithmic form, as it is right now, to exponential form, which I'm about to go to, it'll be written as the base 3 to the second power, this value here on the right side of our equation here. And I have a little something on my screen. Let's get that out of the way. This is going to be equivalent to our value here, that x plus 5 divided by x. Yeah. Just like that. So we were able to rewrite the equation from logarithmic form to exponential form once I was able to condense the problem into having that one logarithm on one side of the equal sign. And then from there, we know that 3 squared is equivalent to 9, right? So I'm going to show that this 9 is over 1. And this is going to be equal to my x plus 5 divided by x. And now that I have it set up like this, notice that I have a fraction set equal to another fraction. So this is going to be an opportunity to use the extremes means method, aka cross multiply. So you know I like to get my arrows popping, right? So I'm going to get my arrows popping on this cross multiplication. Is exactly what I'm going to do here. So I have x times 9. That's going to give me 9x. I have 1 times the quantity of x plus 5. So I end up with x plus 5 like so. And then subtracting x to both sides using that subtraction property of equality, we'll have 8x equals 5. And then we'll be dividing both sides by 8. Oh, yes, we will. That coefficient in front of the variable x. But I'm going to move this over here, if you will. You know what I'm saying? Because I was running out of room. So I wanted to put this over home. Well, I can go ahead and solve it like this. So here, oh, I'm sorry. Yeah, the live chat is in the way. Let me get rid of that. Sorry. So here we're going to be dividing both sides by 8. And I end up with x equals to 5/8. Now, 5/8 is only the value if it does not violate the domain. That's right. That's right, Benita Applebone. We're going to red box this if it's not an extraneous solution. So we have to go back and check in our original problem, our original equation, to see whether or not it's going to violate this value of 5/8, whether or not it violates our domain. So plugging in 5/8 into this quantity here where we have x plus 5, that won't generate a value of 0 or a negative value. So that part is good. And if we plug it in directly here where we have this variable x, then that will also be okay as far as our domain is concerned. Because remember, the value that we're taking the log of cannot be 0 or a negative value. So 5/8 is the answer. So we will, Applebum, red box it. That's right. Here, there you go. I was missing part of my box. Now it is in a box beneath the Applebum. Okay. We got it in a red box. Got to put me on, Bonita Applebum. Drop call quest. So moving on to problem number 3. Solve the equation using the quadratic formula is in the house with problem number 3. We're gonna keep this moving, guys. You know what I'm saying? So that's why I was saying it's important for you to go ahead and spread the word with the stream. Share the stream on your social media, guys. Let's get some people up in here. Let's share the love for all the people that need help with their final exam reviews. So in problem 3, you need to be reminded that the quadratic formula requests the coefficients of your terms in that quadratic equation. Oh, yes, it does. So the first thing is to put it in standard form. Recall that standard form of a quadratic equation is ax squared plus bx plus c equals 0. It's going to be these coefficients, the a, the b, and the c values that we'll use and plug into the quadratic formula in order to solve our problem here. It's not that we had to necessarily use a quadratic formula to solve this equation. It's just that they told us to. So your other option, if you weren't told which property to use or which strategy to use, you could have also solved this using the complete and the square method. Yeah, you could have solved this using complete and square. You could not use the zero factor property in this because it's not factorable. You know, there aren't, if you were to multiply the 2 times the 3 there, you would get a product of 6, and there aren't factors of 6 that would add to give us 12. So that wouldn't help you in this case. No, you couldn't use that. So you would use either the quadratic formula or completing the square. But since they told us what to do, how dare they? You know what I'm saying? Trying to come in my house, trying to tell me what to do. What's wrong with you? So yeah, so they're trying to tell us. They're going to tell us in this problem number 3 to use the quadratic formula. So let's go ahead and identify our values for our coefficients here. The a value will be 2. The b value is 12. The c value is 3. And your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. There's your formula right there, guys. That is the quadratic formula. And if you're taking a college algebra final exam where you will not be given the formulas, you need to practice writing down that formula over and over and over again so you'll have it at the ready during your final exam. Because you know they're going to have a problem like this. You already know that. Well, you have to use a quadratic formula. You better have that quadratic formula memorized. All right, so write it down 1,000 times till you get it, because that's the only way that's going to be, that you'll be able to get it for sure. I mean, at least for me. So I write it down every time, so I'll remember it. Okay, so let's plug in the values. All right, let's plug these values in. So our b value is 12, so this is going to be negative 12 plus or minus the square root of 12 squared minus 4 times 2 times 3, right? Okay, all right, that's all ugly right there. Can we not fix part of that? There we go. Better. It's better. It's better. And then we'll have 2 times 2 here. Nice. There we go. There you go. Doreen, okay. Heading out to ALCL class, which I can stay. That's okay. You can always come back. It'll be posted on our YouTube channel. OPG Slothy. I'm in 9th grade, and I know, very good for learning your quadratic formula. Good stuff, OPG. Then we're going to be simplifying this here. And simplifying, we'll have negative 12 plus or minus the square root of 144 minus, that's going to be 8 times 3. That's going to be 24. You like that? And that's going to be all over 4. Let's go ahead and capture this and take this to the next page so we can have some more room here to work with. We're going to need some more room to work with over here. Let's go ahead and add another page in here. Let's go ahead and add another page, guys. Let's add another page to this. Here it is. It's coming. I got you. You're in good hands. All right. Not with Allstate, but with Mr. Witt. OPG says, I love math. Well, I love you. Look at that. It's cyclical. So here we're going to continue. Well, good stuff on knowing that formula and everything there. That is very impressive. All right. So let's see here. We having, I think, guys, that we are having a technical difficulty here. What is going on? Let's go ahead and get out of this and go back in because it was tripping for a second, guys. We don't want to have any issues here now, do we? Let's see here. All right, so we have that now. All right, that's looking good. We were going to capture this. All right. See, the live stream, you get all the mistakes and stuff. There you go. All right, so now it looks like we're better. We're back in charge now, guys. There we go. There we go. We got it. Classical conditioning. I can dig it. Absolutely desire. And Sander, right, you had the voice of a movie star. That's funny, Sander. I appreciate you. All right. I wouldn't be a star without you. Let's put it like that. So what we're going to do is we're going to go ahead and combine this here inside of the radical. We have a negative 12 plus or minus the square root of 144 minus 24. That gives you 120. This is going to be divided by 4. All right. And then, in Angry Hermit, I was, little known fact, is that I was a member of the Singing Boys of Houston when I was a child. So you may be onto something. All right. There it is. Rosa's in the house. All right. Rosa's in the house ready to get her learn on today. So we need to simplify the radical, guys. That's what we need to do. So simplifying this radical, we are looking for the largest perfect square within 120. That's what we're doing. And for that matter, I believe we can go ahead and use the number 4. Yeah. We can say that 4 is the largest perfect square within 120. Yeah, I think that works. And if we weren't aware of that, you could always break that down using your prime factorization. But the largest perfect square that goes evenly into 120 would be 4. Yeah, there you go. And that's going to be all divided by 4. Now, simplifying this, you'll have negative 12 plus or minus the square root of 4 is 2, which gives us the square root of 30. All divided by 4. And now notice that every element within this result thus far can be divided by 2. So that's exactly what we'll do. We'll reduce every element within this result by 2 here. So simplifying the negative 12 by 2, you'll end up with negative 6. This will be plus or minus 2 goes into itself once. So you're left with the square root of 30. All divided by 2. And this is your answer. Now, this is only one form of the answer. You could have this written in a solution set, guys, where they just go ahead and expand this and say that this is going to be X, and then they'll have their little braces there. That's my ugly brace. That is my ugly brace. That's a little better brace. Let me see. I cannot draw a brace. That's a better brace for me. There you go. And you're going to, let me see. Could you do the division part first? With a negative 12? No, Benita. No, you want to simplify that within the radicand first. So here, you're going to end up with the negative 6 minus the square root of 30 over 2, comma, negative 6 plus the square root of 30. Oh, that is just horrendous, guys. I don't even think I could make out what that was saying. And I wrote it. You know that's bad, right? All right. So that's another way they could have written it. They could have expanded that. In other words, instead of having the plus or minus symbol, they may write it, okay, in this expanded form, showing the negative 6 minus the square root of 30 over 2, and then also having the negative 6 plus the square root of 30 over 2. So you could expand it that way as a solution, okay? So either of these would be red boxed in that case, all right? But, you know, the plus and minus is the simplest way to go ahead and about writing that. You know what I mean? Okay, so that being the case, guys, that completes problem number, what was that? Problem number 3. Yeah, it's done, man. It's over. Let's check out number 4. Let's keep the thing moving. College Algebra, final exam review, number 4 is underway. It says to find the value of I to the 50th power. Now, right here, we're dealing with imaginary numbers. Yeah, and so you need to be already familiar with the sequence that I to the first power equals to I, that I to the second power equals to -1, that I to the third power equals to -I, that I to the fourth power equals to +1. You need to be familiar with that already. All right, there you go. What's going on, Tomeo? Tamaya in the house. What's up? So here's our sequence for our imaginary numbers, and it's just going to continue in either direction in that same sequence. All right. No, it's not really hard. It's not really hard. You just need to be aware of what the steps are in order to solve the problem, Tamaya. All right. So no, it's not necessarily hard. Not hard at all. Just takes some little time to get used to the strategies and tips and whatnot. But if you pay attention to forbidden tutoring, you see what I'm saying? You can learn all of your foundation to do all the problems that you'll see in this review. So what you also need to know about this is that as far as the imaginary number I is concerned, that I is equivalent to the square root of -1. All right. So here is the deal. And Angry Hermit has already put a link in the chat there for you, where you can go ahead and check out that video on imaginary and complex numbers. So there you go, Tamaya. Check that out if you feel that number 4 is challenging to you. But to simplify this, guys, yes, I do teach geometry, but only a few videos have been posted for geometry thus far. But there's a geometry playlist, Tamaya, so you can check that out. But I will be doing a geometry final exam review coming up in a couple of weeks. All right. So just hang on for that if you're able to, and you'll see a geometry final exam coming your way. All right, so continue on with this problem, guys. All you got to do is pay attention to the fact that we have I to the 50th power. And anytime you're trying to simplify an expression like this, okay, Latara, let's not get confused here. Let's focus here. We had a lot of distractions, didn't we? We're starting out with I to the 50th power, Tamaya. Okay, and Latara. All you got to do is focus on the fact that you have an exponent of 50. Take that 50 and divide it by 4. Always by 4 when you're simplifying the imaginary numbers here. 4 goes into 50 how many times? Let's find out, right? So we'll have this. Let's go ahead and carry this over here, guys. We'll divide them by 50. 4 goes into 50. That'll be 1 time. You're going to hit subtract. Bring down to 1 to 0. 4 goes into 10 twice. You'll have an 8. And all you care about is the remainder. And we have a remainder of 2. This remainder of 2, guys, is going to be equivalent to I to the 50th power. So rewriting this as I squared based on this remainder here, we know that that's equivalent because for every 4 i's, you end up with the value being 1. So you're just factoring out I to the 4th power to however many times that occurs until you get to I to the 50th power and have a remainder of I squared. The reason why it's always 4, Latara, is because this sequence has 4 terms in the sequence. The first one is I, then it goes to -1, then it goes to -I, and then it goes to 1, and then it starts over again. So that's why we're always dividing by 4, because the sequence is 4 in length. So, for instance, I to the 5th power, it would be an I. I to the 6th power, it would be a -1. That it just keeps repeating these 4 numbers over and over and over again. That's why we're dividing by 4 always. And if you recall from our sequence, I to the 2nd power is -1. So we have our answer. That's it. It's over. It's over. So all you really need to do here is just know to always divide by 4 and take the remainder, as well as being aware of the 4 terms in the imaginary sequence. Yeah, there you go. I'm sorry, Devin. Sorry about that. Sorry that you didn't have a good result on your final exam. So you may consider, Devin, in the future to get a personal tutor. All right, that's a service that we provide. You can even have me as your personal tutor if you wish. All right, Latara says that she got it now. Kyle says, I'm only in 8th grade and all of this makes sense, trying to learn this before high school. That is a perfect plan, Kyle. You should spend your entire summer, this summer, preparing for your math class that you'll have during your freshman year, and that'll make your high school life that much easier. All right, that's a good plan, Kyle. Keep it up. So, guys, we have problem number 4. It's in a red box. I've given you everything you need to know to solve problems like this. You always take the exponent on your base of I and divide it by 4. That remainder is going to be equivalent to the value that you started out with, and just according to your sequence of I to the 1st power all the way up to I to the 4th power, you'll know what that value is. So in our case, our remainder was 2, so we ended up with I squared, and then we end up with -1. Benita Applebum says, I so love how you teach. I appreciate that, Benita. That is my gift from God to share with the world, and that's what I'm doing right now. I am sharing my gift with the world, guys. And all of you that have God-given talents, and every last one of you should, if you are aware of your God-given talent, you should share your God-given talent as much as possible. That's what I'm trying to do here today. Hey, we have problem number 5. It says, what is the domain of this function? We have f of x equals to the square root of x squared minus x minus 2. And notice, guys, that we have a domain restriction involved in this problem. And what is that domain restriction, you should ask? The domain restriction is that you can't take the square root of a negative value. So when you're dealing with domain questions such as this, they're referring to the real number set. Okay, so they're not involving the imaginary numbers that we just left in problem number 4. Oh no, they want you to be dealing with the real. They want you to keep it 100. Okay, and deal with the real, okay, on this problem here. And so the matter of fact is that our radicand, this value here underneath the radical symbol, the square root sign, cannot be a negative number. So that's the way you start off by finding the domain for this problem here. So we'll start by saying that x squared minus x minus 2 has to be greater than or equal to 0. Oh yeah. And because we already have it set up equal to 0, guys, we can factor the left side because it's factorable. You know, look for 2 factors of 2. That'll subtract to give you 1. That'll be 1 and 2. So we'll be able to factor this out into x minus 2 times x plus 1, which is greater than or equal to 0. And with this, we're going to next find our critical points, the critical values that we need to be cautious of as we work through this problem. And you do that by setting each factor equal to 0. So I'll have x minus 2 equal to 0, and I'm going to solve for that. I'm going to have x plus 1 equal to 0, and I'm going to solve for that this is in order to find out what my critical values are. And what I find, guys, is that one critical value is 2, while the other critical value is negative 1. All right. So for starters, let's go ahead and bring you guys up to speed here. Let's talk about what just happened. We started out by recognizing that our function here. What's going on, Jamila? How you doing? Good to see you. We started out by finding out that our function that we're dealing with was a square root function. The domain restriction for a square root function is that the value underneath the square root sign cannot be negative. So you set that radicand value, in this case is x squared minus x minus 2, you set that greater than or equal to 0, and then if possible, you go ahead and factor it, all right, and you set those factors equal to 0 so that you can identify what your critical values are. We did just that. And we found out, and let's go ahead and use a purple circle here, guys, a purple circle. We found out that, what's up, Angry Hermit in the house? We found out that x was equal to 2 and x equals to negative 1 were going to be our critical values for this problem. Now, let me show you what to do with that information, okay? So, let's go ahead and make another page here. I think I need another page, guys. I need another sheet of paper to work with. All right, here it comes. There we go. So on a number line, we had 2 critical values. Those 2 critical values, to remind you, were 2 and negative 1. Let's put that on the number line. We have negative 1. We have 2. We also were working with 2 factors, right? Our 2 factors were x minus 2, and the other factor was x plus 1. What we want to do from here, okay? Oh, I understand, Angry Hermit. I know you've been here. And what we want to do from here is we're going to show that at negative 1, our second factor would be 0. That at positive 2, our first factor would give us a result of 0 if we were to plug that in. And then we're going to put in a test value. This test value needs to be less than our smallest critical value, which is negative 1. So I'm going to use negative 3, all right, as my test point. This test point will be plugged into both factors, guys, and we're going to create a sign chart. So check me out. Negative 3 going into the first factor, we know that negative 3 minus 2 is negative 5, right? Well, that negative value is all I need to know. Yeah, I just need to know that this was going to give me a negative value. And then after this 2 right here, those values will become positives. Okay, so I'm making a sign chart. Not really caring about the exact values, just a sign of the answer. Okay, so when I plug in negative 3 into the second factor, that x plus 1, all right, we have negative 3 plus 1 gives me negative 2. So that result is negative. Okay, so it becomes negative here, but after that -1, these values that you would find would be positive. Okay, in that second factor. Benita Applebaum, the negative is on the correct side of the line. Negatives are to the left and positives are to the right. All right. Virgil says, this channel helped me a lot last year. Drop it in to say thank you. Good day. Hey, I appreciate you, Virgil. Doing my best to help those in need. All right. So thanks for chiming in. So our sign chart is now complete, guys. But recall what was occurring in this problem. What occurred in this problem is the following. Let's check it out. We said originally that our inequality had to be greater than or equal to 0, right? So, and also that our factors are multiplying. We have a product that needs to be greater than or equal to 0. So let's multiply these factors out according to their signs to see what result they would give us. A negative times a negative will give us a positive. Negative times 0 is just 0, right? We also know that negative times a positive is a negative value. 0 times a positive gives you 0, and a positive times a positive gives you a positive. So these down here are the results of our sign chart that I just used. The result must be 0 or positive, right? Because it had to be greater than or equal to 0. Well, that occurs at -1 and to the left of -1. And it also occurs at 2 and to the right of 2. Because these are where our values that would be plugged into the original inequality would generate either a 0 or a positive result. And that is what we found on our number line. And many times in your final exams, guys, you will be writing this result in interval notation. And we can do an easy job of doing that by checking out the graph that we just created. So we'll start with our left side. Going to the extreme left, we have negative infinity. Going to -1, including -1 with that bracket, union, bracket, 2 to positive infinity. And this is going to be the answer. Benita Applebaum says that I am a genius. I am trying my best to become a genius. I am not genius level yet. Just yet, Benita Applebaum. I am not anywhere near being a genius, but I will red box it. All right, there we go, guys. That is the domain of problem number 4. Amen, amen. Let's keep it moving, guys. Keeping it moving. If that was, hold on. That was number 5. That was number 5. That was number 5. All right, well, that was the answer to number 5 then. All right, and now we're on number 6. All right, I'm trying to look over here at Jamila. What's going on? Look at what, Jamila? We have problem number 6 now. Laughing out loud. Oh, that's what that's supposed to be? Okay, so problem number 6, we want to solve the equation, and we have a rational equation. All right, MJ Plot says, Mr. Witt, my students love your videos. They are taking their final test in college algebra this week. That is awesome. I just sent an email telling them all you are live. Thank you so much, MJ Plot, and congratulations on getting your students to the end of the semester. I hope they all pass. Thank you for spreading the word. That is amazing. And keep me posted on how many of your students actually chimed in. And also, MJ, the video will be posted to the YouTube channel so they can catch it. Even if they can't catch it live, they can catch it on the YouTube channel. It'll be posted in a playlist called Final Exam Reviews. Angry Hermit says, do you think people can become substantially smarter? Absolutely, Angry Hermit. Absolutely. You are smarter and getting exponentially smarter just knowing that you can become smarter. And seeking help or even asking a question like that. You know what I'm saying? You get smarter day by day if you are working on that. All right. So there you go. Use that human brain. There you go. Hey, guys, we're going to do number 6 now. So you need to be aware of your domain restrictions in this equation, guys. All right. The domains of your rational expressions, okay, will exclude any value that would generate a 0 in the denominator. You can't have zeros in the denominator of your fractions. All right. So, for instance, if we had a solution that equal to a positive 1, we couldn't allow that. If we had an answer of -1, we couldn't allow that either as a solution because they will make the equation undefined. You can't have 0 in the fractions, guys, in the denominator. So we're going to begin like this. What's going on, Justin? Good to see you. All right. So Justin says, I'm starting to hear your voice when I use the distributive property software. You better believe it. You better hear me saying arrows popping. All right. Benita Applebum says, I feel smarter once I understand what I'm doing. Hence, Mr. Whip makes me smarter. I am doing my best to help, Benita, but we need to help a lot of people by getting back to this problem. And that's what I'm going to do right now. The LCD of this entire equation is the product of our factors in the denominator. Okay, so what you'll do, or what I'm going to do here, is I'm going to show my work. I'm going to multiply each and every term, guys, in this equation by the LCD of the entire equation, which is x minus 1 times x plus 1. So I have made a product of all of the different factors in the rational equation. Oh, yeah. And that's my LCD. And I'm going to multiply the LCD times each and every term. At first, it's going to be a hot mess. Oh, yeah, it's going to be a hot mess at first because I'm running out of room here. Okay, so it's going to be a hot mess at first, but I'm going to make it clean. I'm going to clean it up. Oh, it's going to get clean. I'm going to clean this up in a second. All right, so you know what? Let's move this over so I can squeeze this 2 in here. I want to put the 2 in front. I want to put the 2 in front, guys. That's what I want to do. All right, so the 2's in front. I'm showing that I'm multiplying each and every term by the LCD. Lion Irvin says, I love you, Mr. Witt. I love you right back, Lion. So multiplying each and every term by the LCD of x minus 1 times x plus 1, we're going to be able to simplify the equation now and eliminate all of the rational expressions. Oh, I cannot wait to do just that because I can't stand fractions in my problems, guys. Can't stand them. Nope. This first term, the x minus 1s will cancel out to leave me with x plus 1. Plus. The x plus 1s will cancel out with the second term to leave me with 3 times the quantity of x minus 1. I'm just taking my time with it, guys. Just taking my time with it. And then on the right side, I'm going to bring down a 2, and I will go ahead and distribute this x minus 1 times x plus 1 to get a result of x squared minus 1, because that's just a difference of squares, all right? So you guys should remember that factoring pattern when you have a plus b times a minus b. That is a difference of squares. So all I did was multiply those binomials together, combine those like terms to give me a result of x squared minus 1 on the right side within the parentheses. Amen, amen. Oh yeah, just handle my business here, guys. From here, we'll go ahead and distribute on the left side, so I will be getting my arrows popping. On the right side, I will be getting my arrows popping, and I will end up with x plus 1 plus 3x minus 3 equals to 2x squared minus 2. Oh yeah. From here, ladies and gentlemen, we will be setting this equal to 0. That's exactly what we'll do. But you know what? I'm going to go ahead and combine my like terms first on the left side. That's what I'm going to do. I'll have the x plus the 3x. That gives me 4x. I know that 1 minus 3 is negative 2. This equals to 2x squared minus 2 here, guys. And we're going to go ahead and carry this on to the next page so we can continue. I need more room. I need more room, guys. Okay? So let's go ahead and hook this up. All right. Add another page. Go ahead and hook this up. There we go. There we have our problem. We got it in view, guys. Y'all can see it, right? Good deal. Let's set this equal to 0. So with that said, I'm going to add 2 to both sides of the equal sign. I'm going to take my time with it, guys. I'm going to take my time. We'll have 4x. The additive inverses cancel out. I'm bringing down 2x squared on the right side. And once again, those additive inverses cancel out. There we go. So we'll now subtract 4x to both sides. And we'll end up with a result that is 2x squared minus 4x equals 0. From here, my boy Kevin and Chino love you. That's what's going on, man. That's what's going on. Kevin and Chino is in the house with Lion Irvin. We're going to factor out our GCF in this equation, guys. I'm going to use the zero factor property. So I'm going to factor out 2x. That leaves me with a result of x minus 2, which equals 0. All right. Dark Knight says, man, if only you got these put before my math final. I'm sorry, Dark Knight. I was working on all of the other final exams that people were doing. So I apologize for that. We have Jamila in the house with a donation of $20. That's what's up. Way to go. Let me see here. Thanks a lot, Jamila. Using the PayPal for that donation here. Let me get my lie right. Let me make sure. All right. Appreciate that. Yep, absolutely. So let's put Jamila in the house. Let's go ahead and hook this up. Well, so we're going to take a moment to recognize that Jamila just got through hooking us up with the donation. All right, there you go. All right, boom, Jamila. That's what's up with you. Jamila's in the house. Thank you for the for the donation, Jamila. You are a blessing to all that we're trying to do. Thank you so much for your assistance there. Word up. All right, so there it is. Let's keep it moving, guys. We are going to set this equal to 0 each factor that contains your variable x, and you're going to solve for each of these. Good stuff. Greetings from Bassett Middle School, says Dark Knight. Greetings to you. Greetings to you. We have x equals 0, guys, as a possibility. We have x equals 2 as a possibility. And recall that we already discussed the two domain restrictions that we had in this problem. We said that we needed to exclude any values that would create a 0 in our original problem. Let's go ahead and take a look at that. We knew that positive 1 would be excluded from our domain. We knew that negative 1 would also be excluded from our domain. So if we had gotten solutions of 1 or negative 1, we couldn't use that in our solutions. But notice that our solutions here that we got right now are 0 and 2. Therefore, both of these are in our domain. So that means we could use these. I can't draw a brace, guys. Did you know that I can't draw a brace? All right, so that's going to be 0 and 2. All right, there you go. Oh, that is just terrible. I can't draw. Okay, that's a somewhat okay brace, guys. We're going to red box it. There we go. 0 and 2. And thanks again, Jamila, for your donation. That was amazing. Once again, guys, just to let you guys know, Benita Abdul says my braces are fine. No, they're not. Mike Weber says, will I be teaching 13-14 at ACC this summer or fall by chance? Yes, Mike. I am teaching college algebra the second summer session at Spring Branch. And I'll be teaching it in fall as well. Thank you for asking. So, guys, I appreciate you chiming in with me, spending time with me. We're about to move on to our next problem. Just to remind you guys to share the stream, like the video, subscribe to Forbidden Tutoring. Adane is in the house saying thank you. You're welcome. You're welcome, Adane. Yay. All right. Good deal, Mike. I look forward to seeing you then. And let's see. We got a $5 donation from Priscilla. Thank you, Priscilla. Every dollar counts. Priscilla is in the house. Let's look up Priscilla. Priscilla, we're going to put you in purple. We're going to put Priscilla in purple right here. Yes, we are. Priscilla Lopez is putting it down with FBT, immortalized on YouTube with your donation today. Thank you so much for the super chat donation, Priscilla. Thanks so much. Let's keep this party going, guys. Problem number 7, it says, solve the equation by completing the square. So in order to complete the square, guys, we need to isolate the first two terms. So we're going to do that by subtracting 1 to both sides of the equal sign. All right. Priscilla said, I had you as a sub and you totally rocked at the Katy campus. That's what's up, Priscilla. That's what's up. I'm glad that I was able to spend that time with you. Been studying soon, much easier. All right. So no, thank you. Oh, it's all good. Hey, it was my pleasure, Priscilla. Thank you so much for your donation. Thank you for giving me a shout out. And I appreciate the time that we spent when I subbed your class at ACC's Katy campus. That's what's going on. That is awesome. That's awesome. Let's go ahead and remove this super chat so you can get your love right there with Mr. Witt. We got Priscilla Lopez giving a donation to Forbidden Tutoring. So once again, guys, when completing the square, you want to isolate the first two terms. And we've done so by subtracting 1 to both sides. From here, we're going to bring down the first two terms at x squared plus 4x. We're going to leave a blank equals to -1. We're going to leave a blank. And then from here, this is going to be the next step in your process. Pay attention, guys. You need to take half of the middle term's coefficient, which is 2, and then square that value. So we took half of 4, which is 2. You then square that value, meaning 2 times 2, and this is the result that goes in the blanks, that positive 4 that you would get as a result. That is what's going on. Benita Applebum asking me to come down to Mount San Jacinto College in Cali. All right. There you go. Tell your administration to give me a holler. Maybe we can make something happen. Then on the left side, we just completed a perfect square trinomial, guys. So we'll be able to factor this, and it will always be your variable in whatever half of the middle term's coefficient was. So in this case, it's going to be x plus 2 squared. It's a positive 2 within the parentheses because that's what half of your middle term's coefficient was. That half of the 4 that we got, that half of that positive 4 that we ended up with, that value of 2 that we ended up squaring, that's why you end up with a 2 here. So I'm going to go ahead and show an arrow to show that that value inside of your factorization will always be half of the middle term's coefficient. So you don't necessarily have to go through a long drawn out process in factoring your perfect square trinomial that you just created. It should always be your variable in whatever half of the middle term's coefficient is. Always. All right. So this is going to be set equal to 3. Oh yeah, and now I have something fun to show you as we solve for x, because we're going to use the square root property, and I'm going to show you the proper way to do it. So let's go ahead and grab this, guys. We'll need to add another page again. Looks like these college algebra problems are lengthy, so you got to get a lot of practice in on it, guys, so that you're going to be familiar with them, so it doesn't take you that long to do. All right, so make sure that you're doing that. And let's go ahead and paste this here, and we're going to continue solving this problem using the square root property. All right, Jerry Hibbs is in the house. What's going on? Thanks for doing this. You're a big help to this semester. Hey, it is my pleasure, Jerry. Thank you for chiming in to the live stream today. Let's go ahead and continue this process, guys, with the square root property. You're going to do that by taking the square root of both sides of the equation. So we'll have the square root of x plus 2 squared equals the square root of 3. Know that every time you use the radical sign, the radical symbol, the square root sign specifically, that they're looking for the principal root. They're not ignoring the fact that the negative root exists, but they only want the positive root when you're taking the square root using the square root symbol. So that means that you need to guarantee that your results are positive when you use this process. We can do that by using absolute value signs. So for instance, on the left side, when I take the square root of x plus 2 squared, your result will be the absolute value of x plus 2 equals to the square root of 3, as I cannot simplify that any further without a calculator. All right, so I know that there's some human beings that can. I'm not one of them. So we're going to leave it in this exact form on the right side as the square root of 3. From here, you're solving an absolute value equation. And because the absolute value needs to always be positive or 0, it can also be equidistant from 0, meaning that I just need to be square root of 3 places away from 0. Well, that can occur at positive square root of 3, or that could occur at negative square root of 3. So that distance from 0 can occur on the left side of 0 or on the right side of 0, which is why you'll end up most of the time with 2 equations to solve from here. On the left side, this first equation will be subtracting 2 to both sides of the equal sign, and you'll end up with x equals negative 2 plus the square root of 3. Or subtracting 2 in the second equation, you'll have x equals negative 2 minus the square root of 3. So we're going to write our answers, guys, as a solution set. So as a solution set, you'll have x equals, and once again, these braces, guys, are going to be the death of me. We'll have negative 2 minus the square root of 3, as well as negative 2 plus the square root of 3 as your solutions. There we go. That's going to be the best I can do on that brace. I can't do it. The braces suck, guys. Red boxing it. That's the answer. That's the answer, guys. And that is also including the proper way to use the square root property. Amen. Amen. Oh, yeah. Let's move on. Let us move on. Once again, thanks to Priscilla for that donation of $5. Thanks also to Jamila for her donation. Remember, guys, please share the stream with your friends and family, the people that you love, the people that you hate, the people you barely know, as well as like the video, subscribe to YouTube channel, click on that bell icon right next to that subscribe button so that you can be notified when we upload videos to help you out in your mathematics academic endeavors. Problem number 8, guys. It says to determine if y equals x cubed minus x is an even, odd, or neither. Meaning that is it an even function, an odd function, or neither even nor odd. Okay, so the way you're going to do this is as follows. Let me go ahead and give you guys some guidelines here. We already know that the variable y in using function notation can be written as f of x, right? Okay, so if f of x is equivalent to f of negative x, then you're dealing with an even function. If f of negative x is equivalent to the opposite of f of x, you're dealing with an odd function. And if neither are the case, then of course then the answer is going to be neither. But this is going to be the rule set that you're going to use to verify whether or not you're dealing with an even function or you're dealing with an odd function, or if you end up with something that is neither. There you go. So let's go ahead and take our initial function here. This is y. All right. So if I say that my original function is f of x equals to x cubed minus x. All right. And I then find out what f of negative x is by replacing all the x's with negative x and then simplifying that. Let's see what occurs. Well, negative x cubed would generate a negative x cubed. See, you had a negative base raised to an odd exponent, so the result would be negative. Then the opposite of negative x is positive x, right? So you can already tell that f of negative x, the simplification of this, doesn't equal to our original function. No, they're not the same. Okay. However, we also need to find out what the opposite of f of x looks like. And that just simply means we're going to change all the signs of the original function. So you'll end up with negative x cubed plus x. Well, lo and behold, guys, let me show you this with a purple circle, that f of negative x was, okay, let me fix that. Let me fix that because I got too happy with the purple circle. That our f of negative x value was negative x cubed plus x. And then the opposite of f of x, the opposite of our function, just by changing signs, was also negative x cubed plus x. And recall that if f of negative x equals to the opposite of our original function, then we're dealing with an odd function. So the answer to this, guys, is that this function is odd. Red, box it. That is how you go about doing that problem right there, guys. That is how you do that there problem. Oh, yeah. So you guys in the chat, go ahead and let me know if that made sense to you for problem number 8. Let me know if that made sense. Give me some feedback on problem number 8, guys. We just red boxed it. Talking about the odd function, the even functions, or neither in that case. Let me know if that made sense to you guys. That was problem number 8. And here we go with our next problem, which is going to be problem number 9. Problem number 9 in the house. Problem number 9 in the house, guys. All right. Okay. Angry Hermit says made sense. Thank you, Angry Hermit. Appreciate that. So here it says Saya's in the house. What's going on, Saya? And Kyle says yes, made sense. Fantastic. Thank you guys for your feedback. Problem number 9. It says to find the equation of a line through the point 2, 1. Thank you, Empress Hodge. All right. Evilise is in the house talking about sort of. Sorry, Evilise. I'm doing good. Well, Evilise, all you had to do is make sure you had those substitutions in place and you're just comparing the original function to the other results. All right. May have to watch number 8 again. I understand. All right. Good stuff. Check that out, guys. Go ahead and make sure you hit that rewind button. Get that one over again. I'm doing good, Saya. Glad you could chime in today. Problem number 9, we are finding the equation of a line through the point 2, 1, and it needs to be parallel to the line 5x minus 2y equals 7. Well, here's the deal. In order to move forward with this problem, guys, we need to first of all find out the slope of the given line. So the slope of the given line can be found by writing this equation in slope-intercept form. So if I take my 5x minus 2y equals 7 and then solve for y, we'll start by subtracting 5x to both sides. That gives us negative 2y equals to negative 5x plus 7. And then we'll divide each and every term by negative 2. Simplifying, you'll then end up with y equals a positive 5 halves x minus 7 halves. Well, that gives me the slope of this line. Well, because the slope of the line, remember this is going to be in y equals mx plus b format. Okay, so the m value is your slope, and that coefficient in front of your variable x is going to be 5 halves. So our slope is 5 halves. And what you need to know as a math student is that the parallel line slope must also be 5/2. So anytime you're dealing with parallel lines, the slopes must be identical. They have to be the same. So parallel lines have the exact same slope. They have the same slope. All right. Took an orange juice break, guys. No pulp. So here we have the slope. The parallel line slope must also be 5/2. So now that I have the slope that I need, as well as the given point of 2, 1, we can use the point slope form to solve for our equation. All right, to write our equation, and we'll write our equation in slope intercept form. The directions didn't tell us. It just said to find the equation of a line through that point. So we'll write our answer in slope intercept form using the point slope form to get there. All right, so let's go ahead and grab this. And we'll go ahead and add a page again. All right, so I did not anticipate that I needed this many pages per problem. That's on me, guys. Didn't mean to waste your time like that. All right, so here we go. So we know that we have a slope, the parallel line slope. Okay, let's fix that. The parallel line slope is 5/2, and we'll be going through the point 2, 1. All right, let's go ahead and verify that. Yep, the point is 2, 1, and our parallel line slope is 5/2. We're going to use the point slope form to write our answer in slope intercept form. All right, so let's go ahead and start by labeling the point as x1, y1, and we'll plug this information in to the point slope form. So we'll have y minus my y1 value, which is 1, equals to m, which is 5/2, times x minus my x1 value, which happens to be 2. All right. From here, we're gonna go ahead and distribute, get our arrows popping in order to solve for y. So I'll be distributing here that 5/2 inside of the parentheses. Got my arrows popping. Thank you. So we'll end up with 5/2 x, and then 5/2 times -2 just gives you -5, as the 2's will cancel out. Now, in order to isolate the variable y, you'll be adding 1 to both sides of the equal sign. So you'll end up with a result that is y equals 5/2 x minus 4, and this is your answer for problem number 9. Red, box it. There we go. So that was finding the equation of a line that was parallel to a given point and a given line. Amen, amen. Let's move on to our next problem, guys. Here we go. Problem number 10. It says to solve the equation by making an appropriate substitution. We're given x to the 2/3 minus 2x to the 1/3 minus 8 equals 0. And what I see, guys, is a lot of rational exponents. All right. I see a common base of a common variable of x. And I see a common denominator of 3 in those rational exponents. Evilise says, I'll have to watch this later. Got to run. Good stuff, Mr. Witt. Hey, appreciate you chiming in, Evilise. Good to see you again, lady. See you again soon. All right. So what we're going to do is I'm going to make up a variable to use in this problem because it looks a hot mess right now. Okay. It looks a hot mess and I'm already freaking out. Okay. So in order to simplify this, all right, we're going to do the thing. Soft Profit Airman TV, what's going on? How you doing? Thank you for chiming in today. Let's go ahead and show you some love here and put you guys back on the screen. We're going to say that y is equivalent to x to the 1/3 power. Okay. That being the case, I can also say that y squared could equal to x to the 2/3 power. Because remember, in squaring that value, I would just need to multiply the exponents, and 1/3 times 2 is 2/3. So if I say that y, and remember this variable I'm literally making up, so your variable could have been, D or A or C or whatever variable you wanted to use. I'm going to use the y variable, okay? And I'm saying that y equals to x to the 1/3, and that y squared then must equal to x to the 2/3. With this, I'll be substituting these values into the original equation, all right? So let's see here. Say it says, Mr. Witt, there's something wrong with your screen. We can see the chat on it. No, I did that on purpose, Saya. I wanted you guys to see the chat. So we're good. I'll be taking it off once it gets in the way, all right? So then, plugging these values in, we'll have y squared minus 2y minus 8 equals 0. So by substitution, Okay, by substitution, we were able to rewrite the equation into a more simplistic form. All right, because it doesn't look as dangerous. It doesn't look as intimidating without those variables with the rational exponents on it. All right, what's going on, Matthew Hawk? All right, good to see you. Hi from Germany. Good to see you there. Thank you for chiming in, saying what's up from Germany. All right. Well, I am chiming in live from Houston, Texas, in America, the United States of America. Thanks for joining us today. All right, so let's factor this using the zero factor property. We will be looking for two factors of 8 that will subtract to give us 2. That would be 4 and 2. So factoring this out, you'll have y minus 4 times y plus 2 equals 0. And then we're going to set each factor equal to 0 and solve for it. So our first equation is going to be y minus 4 equals 0, and we'll also have y plus 2 equals 0, and we'll solve for each equation. First, we'll end up with y equals 4 by adding 4 to both sides. The second equation will yield negative 2 as a result, as we subtract 2 to both sides. And it's at this point that in order to solve for x, we'll need to use these values, all right, and we'll put them in purple here, purple circles on their way, that we'll be using these values of 4 and negative 2 to solve for x. So let me go on to another screen to show you guys exactly what that looks like. All right, so once again, we need to add another page. We need to add another page, guys. Got me working today. Look at you guys. Putting Mr. Witt to work. All right, so we said earlier that we end up with a result of 4 and negative 2. All right, and we had them in purple circles, and they went away on us. There we go. We had 4 and negative 2 that we can use for our values of y. So remember, guys, that if y equals to 4 and negative 2 as solution sets here, those are supposed to be braces. So if y is equivalent to 4 and negative 2, remember we already said that y was equivalent to x to the 1/3 power, right? So that being the case, we are going to substitute in those values and solve for x. So one equation will read x to the 1/3 equals negative 2, and we'll also have a result that says x to the 1/3 equals to positive 4. So in order to solve for x, we're going to do the reverse of our rational exponent, the reciprocal of it. We'll be cubing both sides in order to solve for x. So we'll have x to the 1/3 raised, all right, let's say that it's all raised to the 3rd power, and we'll have to raise that negative 2 to the 3rd power as well. So on the left side, the 3's will cancel out, and x equals negative 8 as one of our solutions. And then on the right equation here, we'll also be cubing both sides of the equation so that we have x equals 64. So your solutions for this problem is going to be negative 8 and 64, as those two results would work in our original problem right here. All right, so you can always plug your results back in to verify that your answers work in the original equation. Make sure that you don't have any extraneous solutions. All right, so that's supposed to be a negative 8 and a positive 64 as our results for problem number 10. Done and done. All right, there it is, guys. Red boxed it. All right, we're on to problem number 11 now. Problem number 11 with another logarithmic property. Here it says to find y such that log base 2 of 1/32 equals y. All right, Jamilio's in the house. Isn't the denominator the index? Yes, Jamilio. And when you're dealing with rational exponents, the denominator of a rational exponent is the index of the problem, if you were to write it in radical notation. There you go. Or even if you don't, it is the index, bottom line. It's the index of the problem. That is a good point, Jamilio. That was talking about Jamilio was referencing problem number 10, guys, with that one. Absolutely. Good stuff. But you used it as an exponent? Yeah, I did, to cancel it out, because I needed that variable to be to the 1st power. 1/3 times 3 gives me 1. I wanted to solve for x to the 1st power, so that's why I used that. So in problem number 11, it says find y such that log base 2 of 1/32 equals to y. Guys, we're going to start by recognizing that our problem, this log base 2 of 1/32 equals to y. Because my logarithm has a base of 2, I can rewrite this quantity here, showing that it is also can be written as a base of 2. So for instance, 32 in the denominator could be written as 2 to the 5th power. Can I get a better 2, a better 5? There we go. Yeah, so 32 can be rewritten as 2 to the 5th power in the denominator there. It still equals to y. Then showing that this base, when moved to the numerator, would become 2 to the negative 5th power. That equals y. One of your logarithmic properties says, guys, that once you have your base, your logarithmic base is identical to the value that you have there raised to a power, that this cancels out to give you this result right here. So in other words, y equals -5. That is going to be one of your logarithmic properties, ladies and gentlemen, that allowed me to do that. Oh, yeah. So once I recognized that my base in my logarithm was 2 and that 32 could be rewritten with that exact same base raised to an exponent, that I was able to use a logarithmic property that allowed me to cancel that out to leave me with just the exponent as my result. So the answer to this is -5, red, boxing it. Amen, amen. And that is the case for that problem, guys. So once again, we are going to be sharing the stream with our loved ones and the people that we hate, can't stand. Send them the stream anyway. We're on problem number 12 now. And also like the video, guys. Subscribe to Fort Bend Tutoring. And if you're able, donate, as that helps Fort Bend Tutoring spread free math tutorials around the world. That's what we want to do. We want to help out as many people as we can, and we can do it with your participation, not only in just joining in the live streams and viewing the content, sharing the content, as well as donating. All right. Good stuff. That's right. Bonita Applebum, many professors like for you to show your work. That is correct. There you go. All right, so we have problem number 12, guys. It says to write the slope-intercept form of the line through the given point that is perpendicular to the given line. And we have a given point of -8, 6. We have a line that's given to us that is 9x minus 45y equals 6. And we're asked to write the equation in slope-intercept form. All right, so that means that we're going to do a similar process to the problem that we did before, where we need to solve the equation for y as a way to find out what the slope of the line is. Okay, and I'm going to start out by doing that. Let's just start out by subtracting 9x to both sides of this equation. Okay, I'm going to be bringing down -45y. This equals to -9x plus 6. I will be dividing each and every term by that coefficient of -45. Just like so. The -45s cancel out, and we will end up with y equals -9 -45 will reduce to 1/5 x minus, and then 6 and 45. 3 goes into 6 twice, and 3 goes into 45 15, so that'll be -2/15. So we end up with a slope of 1/5. However, this is going to be a perpendicular line, guys. So with a perpendicular line, you need to find the opposite reciprocal of the slope that you just found. So if our slope for this line is 1/5, is positive 1/5, the perpendicular line slope is going to be -5 once you simplify it. So you flip it and change the sign. So remember that 1/5, you flip that, you'll get 5/1, and then you change the sign on that to get -5. There you go. Yeah, we'll need to go to another page, obviously. I've run out of room. Yeah. Okay, so let's go ahead and take the fact that we know that our perpendicular line slope is -5. We'll be going through the point -8 and 6, and we'll be adding another page once again. Man, you guys better have some scratch paper when you're doing your final exams, because I need scratch paper for days. Okay. All right. So we found out that our perpendicular line slope is -5. We also know that the point that we're going through is -8, 6. And let's just verify that real quick here before we move on. Yeah, the point is -8, 6. And we did say that our perpendicular line slope was -5. Okay, cool. All right. And this time I'm going to create the line in slope-intercept form using just that, slope-intercept form. So slope-intercept form, guys, is y equals mx plus b. And when you're using slope-intercept form to create your line in slope-intercept form, to write your line in slope-intercept form, we're going to label the given point as x and y. So now that I know that my slope is -5 that I need, that I have a value of x of -8, I have a value of y that is 6, I'm going to plug these values into the slope-intercept form and solve for y. Excuse me, I'm going to solve for b. All right, I'm going to solve for b. That's what I'm going to do. All right, so plug it in. We'll have 6 equals -5 times -8 plus b, and then we want to solve for b. So this gives me 6 equals 40 plus b, and then subtracting 40 to both sides of the equal sign here, you'll have -36, -34, which equals to b. And now with our value of b, and I hate that equal sign, so let's fix it. Thank you. So we'll end up writing our equation in slope-intercept form as y equals -5x minus 34. And this is the equation of the line in slope-intercept form that is going to be perpendicular to the given line of, what was that given line? The given line was 9x minus 45y equals 6. That goes through the point -8, 6, and done. That's right, Benita Applebum. We are going to red box it. That's exactly what we're going to do, guys. Red boxing it. Tim Bell says, best professor on YouTube. Thanks again for it, Ben. Hey, my pleasure. And thank you so much for the compliment. Doing the best that I can with problem 13, guys. Problem 13. Let's keep it moving. It says to find the vertex of the parabola. We have y equals x squared plus x plus 5/4. That's what you got. Okay. So let's make this happen. So you have several choices here. The standard form of a quadratic formula or quadratic equation is going to be y equals ax squared plus bx plus c. All right, let's fix that 2. I hate the 2. I hate the 2. The 2 sucks. Better 2. That's a better 2 there. And what we'll do with this is we'll use the vertex formula. Okay, so the vertex that we're trying to solve for is normally labeled as hk. Okay, so the x value of the vertex is h, the y value of the vertex is k, and that being said, the h value, we can find that by using the formula -b divided by 2a, whereas your k value, you'll just need to plug in your value of h into the original equation and solve for it. Okay, and let me get that chat out the way because you can't see the formula. There you go. All right, so these are going to be the formulas that we can use to find the vertex of the parabola here. So that means that you need to know that your a value is 1, that your b value is 1, and that your c value is 5/4. Not that we need it for this problem. Okay, so those are the coefficients of our quadratic equation, and we're going to use that to solve for the vertex. So h being equivalent to -b over 2a, plugging in those values, we'll have -1 over 2 times 1. So that gives you a result of -1/2 for your h value. Let's go ahead and put that in a purple circle. There we go. Then to solve for k is going to be equivalent to f of -1/2, which means that you replace all the values in your original equation with -1/2 and simplify it. So we'll have -1/2 squared plus -1/2 plus 5/4. And then, of course, we need to simplify that result. So let's go ahead and take this to the next page and continue the process. Once again, needing another page. Mr. Witt needing another page. All right. You guys doing all right? You hanging in there with me? All right, I'm trying to hang in there with you guys. Jamila said, not really. All right, so you guys talk amongst yourselves. I see ya. I see ya. Done and done. All right, so here we have it, where we're going to be simplifying here. We have -1/2 squared. That gives you 1/4. And then not the opposite, but if you were to combine these signs here, a positive and negative will combine to give you a negative. So that's going to be negative 1/2 here, plus 5/4. All right. And then, will I be doing any matrices? Not in today's part 1, but you'll probably see some matrices in part 2 beneath Applebaum. So, continuing on with this, we'll end up getting a common denominator, right? Which will be 4, right? So if you had to multiply that denominator by 2, multiply the numerator by 2, you'll end up with negative 2/4. And now, simplifying this, we'll have 1 minus 2 is negative 1. Negative 1 plus 5 is 4. And so you'll have 4/4, which is 1. Which means that your vertex, guys, is negative 1/2, 1. Yeah, there you go. And there it is. Done and done. We're going to red box it, because that's the answer. This is the vertex of your parabola. That was one method to solve for that. You could have also changed it and put it into vertex form using completing a square, but since they didn't ask me to, yeah, I just took the easy way out. Thanks. That's what happened. So the vertex of our original equation, y equals x squared plus x plus 5/4, is going to be negative 1/2 and 1. Yeah. All right. So we got the chat active, Angry Hermit, Saya, and the crew keeping the conversations going over there. Good stuff. Benita Applebaum asking about matrices in this part 1 of the review. We'll probably include a couple in part 2 because I don't have any for part 1 as far as the matrices are concerned. I wanted to make sure I had that logarithms and stuff like that involved, as well as other things like synthetic division. Okay, so look at problem number 14, guys. It says use synthetic division to find the remainder when f of x equals x cubed minus 3x squared minus 3x minus 32 is divided by x minus 5. When you have a situation like this, Benita Applebaum says that he will look forward to that. So will I. You'll take your divisor, that x minus 5, set it equal to 0, and solve for x. That's going to be your first step here. Okay. So you'll end up with x equals 5. It's this value of 5 that you'll use in your process for synthetic division. So I'm going to put 5 on the outside here, and using synthetic division, I'll need the coefficients of the original equation. So those coefficients are 1 from that 1x cubed, negative 3 from the negative 3x squared, negative 3x squared, the negative 3 from the negative 3x term, and negative 32. All right. They want us to find out the remainder. Okay, so let's go ahead and get the chat out the way real quick. And you'll start by bringing down this first value of 1. You'll then multiply 5 times 1 to get 5. Then you'll find the sum of negative 3 and 5 to give you a positive 2. Multiplying 5 times 2 next, you'll end up with 10. Finding the sum of that, negative 3 and 10, give you a sum of 7. All right, I hate that 7. Let's fix it. There we go. That's a better 7. All right, I think that 7 is better. Okay. Then multiplying 5 times 7, you'll end up with 35. And the result of negative 32 and 35 is 3. So it's this last value that's going to be the remainder of your result here, the remainder of this problem here. That's what they wanted. So 3 is the answer. Done and done. All right. That's problem number 14, guys. And let's keep it moving. That was problem number 14. We have problem number 15. That was synthetic division, guys. So we have a video on synthetic division if you need to see more examples of that. All right, problem number 15 is next. It says to solve the radical equation and check all proposed solutions. We have x minus the square root of 3x minus 2 equals 4. X minus the square root of 3x minus 2 equals 4. And the first thing I want to do in this problem is isolate the square root sign. Because it's not doing me any good right now. No, it's not. Let's go ahead and square. Excuse me, not go ahead and square. Let's go ahead and isolate the square root sign first by subtracting x to both sides of the equal sign. So I'll end up with negative square root of 3x minus 2 equals negative x plus 4. And I'll also go ahead and divide each and every term by -1, or you can multiply each and every term by -1 to get rid of that negative in front of the square root sign. All right, you don't have to, but it's annoying me, so I will. So I'm going to end up rewriting this as the square root of 3x minus 2, which equals to x minus 4. All right, once I have this, all right, thanks a lot, Angry Herman, for that link for synthetic division. Appreciate that. So now we'll be squaring both sides. All right, so squaring both sides of the equation, you'll have the square root of 3x minus 2 squared, and you must square the right side as a binomial. You can't do it individually. That'll give you an incorrect answer if you just try to square the x and just try to square the -4 by itself. That'll give you a wrong answer. So guys, make sure you don't do it that way. So instead, you'll take that right side as a polynomial, as a binomial, and square that x minus 4 within the parentheses and have it done that way. On the left side, we are going to cancel out the square root and the square to give you 3x minus 2. And I'll be expanding the right side, so you'll have x minus 4 times x minus 4. And once we have this, we're going to multiply. We're going to distribute out the right side. So let's go ahead and grab that, all right? So grabbing the right side here, we're going to copy this and create another page. All right. Let's go ahead and put this over here and paste this. All right, good. Okay, so what we want to do is go ahead and multiply our right side out. So I'm going to get my arrows popping. That's what I'm going to do. All right, and once again, of course, it's giving me a hard time. So let me get back in here. Let me get back in here because it was giving me a hard time. All right, does it still have it? Yep, it sure does. All right. Oh, my goodness, it's still tripping. Okay. I see you guys want to minus 4x minus Hey guys, can you hear me now? Can you hear me? Can you hear me? All right, testing, guys. Sorry about that. Had some technical difficulties. I apologize for that. Definitely gonna have to go in and fix that mishap in the stream. That was a new one for me. Oh yeah. that was different. Jamilio, does it happen? I didn't know it happened like that. Never happened to me, but there you go. That was a trip. But we have work to do we not? So let's get back to it, guys. Let's get back to it because that was frightening. Oh yeah. That was pretty frightening. Okay. So what happened here, guys? And let's go ahead and backtrack a bit because I don't know at what point I lost you guys, but I do remember that we were about to get our arrows popping, and that's where we were at the time. And we have 3x minus 2 equals x squared minus 4x plus 16. And then we will combine our like terms on the right side. We have 3x minus 2. This gives us x squared minus 8x plus 16. And then we'll be setting the equation equal to 0 by subtracting 3x to both sides, as well as adding 2 to both sides of our equal sign to get our equation set equal to 0. Simplifying this, guys, we'll end up with x squared minus 11x plus 18, and this equals 0. And now we're looking for an opportunity to use a zero factor property, hopefully. That means that we will be needing 2 factors of 18 that add to give me 11. That would be 9 and 2. So this gives me x minus 9 times x minus 2. That equals 0. And then setting each factor equal to 0, you'll have x minus 9 equals 0 and x minus 2 equals 0, and solving for x in each. So in the first equation, I'll add 9 to both sides to get x equals 9. In the second equation, I'll be adding 2 to both sides and find out that x equals to 2. But remember, our results must work in the original equation. So even though we got x equals 9 and x equals to 2, these may be extraneous solutions. So let's see. It has to work in the original equation. So let's try 9 for instance. 3 times 9, guys, gives us 27. 27 minus 2 is 25, and the square root of 25 is 5. So does 9 minus 5 equal to 4? Yeah, it sure does. It sure does. So 9 is a valid solution. We can definitely use 9. Let's go ahead and put that in a purple circle for now. All right, then trying the positive 2 as a result. Yeah, it was positive 2. Trying positive 2 as a result, we would have 3 times 2 is 6. 6 minus 2 gives us 4. The square root of 4 is 2. And we'll have is 2 minus 2 equal to 4. Well, no, it's not. 2 minus 2 is not equal to 4. So that means that because that second value, that negative, since that positive 2 did not work in the original equation, then our only solution here is the number 9. So therefore, our answer to this problem is x equals 9, and we're going to red box it just like that. Red boxing it. Yeah, that's what happened, guys, because plugging 2 back into the original problem did not equal the right side of our equation. Therefore, we only had one solution, which was 9. The extraneous solution was positive 2, which did not work in the original equation. So don't be satisfied with just solving for x, guys. You got to make sure that you are plugging those results back into the original problem and making sure that they work on the original problem. All right, good deal. Let's move on to problem number 16. With problem 16, it asks us to find the distance between the point -2 and 5 and 3 and 4. 3, 4. The point's 3, 4. Okay, so because we are looking to find the distance between 2 points, we'll be using the distance formula, which is distance equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we can use this as our distance formula to find the distance between the 2 points. All right, so now that we have this, let's label the points x1, y1, x2, and y2, and then we'll plug in these values into our equation here for the distance formula. So for x2, we'll have 4. No, we don't. No, we won't. For x2, we'll have the value 3 minus -2 squared plus 4 minus 5 squared. From here, we can combine these signs in that first set of parentheses, and that gives us 3 plus 2 squared. And I'll just bring down this 4 minus 5 squared for now. From here, you'll have 5 squared plus -1 squared. Well, this will give you the square root of 25 plus 1. So our answer here is the square root of 26. And that's it. Red boxing it. Just like that, guys. That's it. So you need to be aware of the distance formula when solving a problem like this. Okay? So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the result that you would get for the distance between 2 points. All right, good deal. All right, good stuff. So Angry Hermit says, I want to draw, so I'm going to cut out early. I understand that. Thanks a lot, Angry Hermit, for helping out. Fabiola's in the house. Good stuff. Problem number 17. It says, given that f of x equals to 3x squared minus 2x plus 5 and g of x equals to 3x minus 1, they want us to find the composition of g and f. So when you see this composition, this little bitty symbol right here, this little circle, that means to find the composite of the two functions. So this also means g of f of x. Okay, so those things are equivalent to one another. So in other words, you want to put the entire function of f into every variable x that you see in the function g. So it's basically substitution, then simplification. So that being the case, we're going to write our function g. In other words, I'm going to have g of 3x squared minus 2x plus 5, in other words. That's what I'm going to end up with, because I'm replacing every x in our g function with the entire function of f, which is 3x squared minus 2x plus 5. So rewriting g using f, I'll have 3 times the quantity of 3x squared minus 2x plus 5, and then that'll be minus 1. So at this point, we'll get our arrows popping, and then we'll simplify from here. So simplifying this here, after I get my arrows popping, we'll have 9x squared minus 6x plus 15 minus 1, and then we'll combine our like terms to get 9x squared. I hate the 2. We'll have 9x squared minus 6x plus 14, done and done. And that's the answer. That's the composition of G and F. That's it, guys. Yeah. What'd you think? Not bad, huh? For number 17? Not bad? All right. So once again, guys, please share the stream now that we're back on. Share the stream with people so that people will know that we're alive still and we're getting things done here. As well as like the video and subscribe to Forbidden Tutoring. Hit that bell notification so you can get notified when we are broadcasting and uploading videos. And if you're able, please donate, as that helps us with our cause to help people with free math tutorials. You can use that little dollar icon at the bottom of your super chat window there, or you can use the donation link in the description box. For number 18, it says to solve the inequality, graph the solution set, and write the answer in interval notation. So here we have an absolute value inequality, right? So the way we're going to do that is, if it starts out with a less than or less than symbol, if it's set up this way, then this is an and situation. This is an intersection. Okay. It's an intersection, and it's an and scenario. If it was a greater than or equal to, then you would be looking at an or a union scenario, okay, as far as the inequality goes. So for starters, it needs to be a possible situation. Remember that your values for your absolute value, the end result of it has to be either positive or a zero value. So is zero less than 7? Yes. Are there positive numbers that are less than 7? Yes. So the first thing we're doing is seeing whether or not we're analyzing the equation, the inequality rather, to see if it's possible. And because we know that there exist positive numbers that are less than 7, and because 0 is less than 7, this inequality is possible. You'll set up two inequalities to solve this, guys. The first one is going to be 5x minus 3 is less than 7, and 5x minus 3 is greater than negative 7. So when it comes to setting up your second inequality, you'll need to change the inequality symbol. See, I flipped it, as well as change the sign on that value of 7. Okay. Then you'll solve for each. So here we're going to add 3 to both sides. This gives us 5x is less than 10. Divide both sides by 5, and we'll have x is less than 2. And in our other scenario, we'll be adding 3 to both sides. You guys see I'm still frazzled from that technical difficulty there. So I'm going to be dividing both sides by 5. So we'll have x is greater than negative 4/5. Yeah, I hated all of that. Let me fix it. Okay, that's a little better. So now that we have this, okay, and you guys go ahead and let me know if you're following along thus far, that we're going to be placing this result first on a number line, and then we'll use that number line to create our interval notation. So let's go ahead and borrow this for a second. Hopefully it won't freak out like it did before. Okay, copy that and move on. Let's go ahead and add a page. All right. All right. Cool. All right, so now that we have this, we're going to make a number line here. And on our number line, we'll need 2 values. We'll need negative 4/5 as well as 2. Okay? And what we're showing here is that We have x being less than 2, so we'll use parentheses and it will shade toward the left. And x needs to also be greater than negative 4/5. So I have parentheses and we're shading toward the right. So it's going to be trapped in between because the intersection is what those two solutions have in common. The intersection is what those two solutions have in common. So as a result in interval notation, our answer is going to be negative 4/5 and 2. And this is the answer for this problem. We're going to red box it. Just like that. Red box it, guys. All right. So, Saya, you still out there, sir? Go ahead and give me a chime in. Let me know that you guys still hear me, can see me, and all that good stuff. As we move on to problem number 19. All right. Red boxed it. Thank you, Saya. Appreciate you. So, in problem number 19, it says, find the midpoint of the line segment whose endpoints are 2, 7, as well as, thank you, Benita Applebaum, appreciate it, as well as negative 6 and 1. That's what we got. So that being the case, the formula for finding the midpoint is as follows. So in finding the midpoint, you'll use the equation x1 plus x2 divided by 2, as well as y1 plus y2 divided by 2. All right, just like that. So we're going to label the points first. So we'll have x1, y1. You're just trying to find out the midpoint between 2 points, between 2 endpoints. So we'll start out by labeling the points x1, y1, x2, y2, and using this formula for the midpoint right here. So notice how labeling will help us through this process, as you got all these variables that they're requesting throughout the whole formula here. You want to have everything identified. So that gives me 2 plus negative 6 divided by 2. We also have 7 plus 1 divided by 2. And we'll be simplifying this. We know that 2 plus negative 6 gives me negative 4. So I have negative 4 over 2. Then with the second one, we have 7 plus 1, which will give me 8 divided by 2. And then finally simplifying this, you'll have negative 2, 4 as the midpoint between those two endpoints. And we have red boxed it. That was problem number 19. Amen, amen. All right. Let's go ahead and wrap things up with problem number 20, guys. I did have intentions on doing more for you guys today, and I'll, of course, be doing some more for you on Saturday, but for whatever reason, we had a lot of technical difficulties, and that just put a slow down on everything that we wanted to accomplish today. All right. Thanks, Benita Applebaum, for making it known that I made it look easy to you. All right, cool. So let's go ahead and knock out problem number 20. All right. So in this problem, it says the slope of a line which is perpendicular to the line y equals negative 2x plus 6 is. Well, for starters, you want to be able to identify that using the slope-intercept form, which is y equals mx plus b, that your slope of the line is going to be negative 2. So the slope of the given line here is negative 2. Jamilio said red boxing it. Exactly. So since our given line, the slope of the given line here is negative 2, that in order to find the perpendicular line slope, you want to flip this slope and change the sign. So notice that I wrote the negative 2 as negative 2 over 1 to show it as a ratio. We're going to then flip that and change the sign. So instead of it being negative, it will now be positive. And flipping that, finding the reciprocal, you'll end up with 1/2. And this is going to be the result. And you know what, guys? That was so fast. I think we better go ahead and do another problem. Yeah. Let's finish up with 21. How about that? With 21, we'll have solved this equation. We have 6 raised to the x minus 3 equals to 36 raised to the 4 minus 3x. This is an exponential equation, guys. All right. So I'm glad that we moved on to this one at least, so you can have an example of that. So with this exponential equation, we can show that we can write this with a common base of 6. So we'll leave the left side as it is, at 6 to the x minus 3. But that 36 is equivalent to 6 squared, right? And that's raised to the 4 minus 3x. Well, once we have it written this way, I can show that we can rewrite it as 6 to the x minus 3 equals to 6 to the, distribute that 2 with that quantity that we have for our Xbox. All right, not for our Xbox. Sorry, I'm thinking about video games that we have as our exponent. That's what I wanted to say. I said Xbox. So we'll end up with 8 minus 6x. There we go, after distributing that. So RTB said that he needed this. Fantastic. So I'm glad I went ahead and did that additional problem. All right. So because our bases are the same and because of the equal sign that they share, the exponents must be equivalent to each other. So we can now set the exponents equal to each other now, guys. So we can say that this is x minus 3 equals to 8 minus 6x. Now that we have that, we can go ahead and solve for x now by adding 6x to both sides. So now that we're adding both sides by 6x, we'll have 7x minus 3 equals to 8, and then adding 3 to both sides, you'll have 7x equals to 11, and then dividing both sides by 7, you'll have a result of x equals to 11/7, and we will be red boxing it. You better believe it, guys. So this is Mr. Witt with Fort Bend Tutoring, guys. This was part 1. This was part 1 of our college algebra final exam review. Sorry for the hiccups today with the technicals, with the technicalities and whatnot, but we got it back on track, and I appreciate all of you guys chiming in. Benita Applebaum chiming in, Jamilio, Saya, of course. We had Angry Hermit. We had quite a few people, Fabiola up in here. We also had Tim Bell chime in. We also had, let's see here. We also had Mathahawk from Germany chime in. Jamila was here. Evelise was here. And Empress Hodge was here. Kyle was here. And others. Priscilla was here. Lion Irvin was here. Mike Weber was here. Priscilla had the donation, so thank you for so much. KK was also here in the house. Adane was in the house. Dark Knight was in the house. Justin Norwood was in the house. And we want you guys to join us on Saturday as we continue with the College Algebra Final Exam Review. On Saturday, make sure you click on that bell icon. And as always, please rate, comment, and subscribe. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. Thanks for